Hey everyone, so I'm going to talk about Newton's law of cooling today with you. Basically, Newton's law of cooling is an exponential function that describes how a body, an object, is either cooling or heating up, depending on the constant that is from the E. This is very useful in physics to describe an object that will be put into a warmer area or be put into a colder area. So everything in this formula has a meaning, and it means something in comparison to a scenario. But before we get to our first scenario, I'm going to talk about what everything means. T of T describes the temperature after a certain time T. So a temperature after T, which is time. That means T is time. And that can be done in minutes or hours, depending on the situation. T of A is called your ambient temperature, and that's basically the temperature of surroundings. TO is the initial temperature of your object. E is a constant, which is approximately 2.718, and K is your decay constant, because this formula does decay. All right? And when you're reading through a problem, just try to think, what is everything they're giving to me? What does it mean? And then it'll be very easy to plug into the formula. So for this example, I'm not going to solve anything. I am just going to go through what everything means. For the specific formula, you have a hard-boiled egg at temperature 100 degrees Celsius. That is T of 0. So basically, that means that your object is starting at 100 degrees Celsius. And then you place it into a 15 degrees Celsius water to cool. And that is actually your ambient temperature, because now the egg is going to a new environment with a new temperature, which is 15 degrees. They say 5 minutes has passed. That's time. And after 5 minutes has passed, so T of 5, you receive 55 degrees Celsius as your egg temperature. Now, if you realize with your formula, you have T of T equals T of A plus T naught minus TA e to the negative KT. Now, if you plug everything in, you know that T of T is going to become 55, TA is 15, T naught is 100, minus 15, e to the negative K times 5. So basically, they give all this other information in the beginning in order to find K. And once you find K, then you can answer this question. When will the egg be 25 degrees Celsius? So now they give you a new T of T, 25 degrees, and they're asking you what value of T is going to go with that. And it's going to be the same initial and the same ambient temperature. Okay? If you solve for this on your own, you should end up getting a K value of 0.1507. And then when it's all said and done, that's your first part. Your second part is to find that T value, and you should end up with 14.2 minutes. So try it on your own. If you need any help, ask me during class. So there's a lot of different resources you guys can look up on YouTube. So if you go to Google and you type in Newton's law of cooling practice problems, you can definitely find a lot of different PDF files and a lot of different places where you can practice scenarios of Newton's law of cooling. But the great thing is when you go to the videos areas, you're going to see all these different examples that are gone through by other teachers and by other websites that may help you practice this theorem. So I hope this helped. I'll see you guys during class tomorrow.